Hey, sixth graders, we are on to Unit 8. This is a new unit and it's all about interpreting data and statistics, which has to do with reading graphs, writing graphs, understanding graphs. So our first lesson is all about making sense of data. And data is just numbers of different things. So let's go ahead and get started. So there's a little definition at the beginning. Numerical data involves numbers and quantities. One example of numerical data is the number of students in your class. The answers to these questions involve numerical data. How many students are in your class? How does the number of students in your class compare to the number of students in other classes in your school or in your city or state? For each group of people named below, describe a kind of numerical data that could be collected. Then decide if you would expect all the data to be the same or if you would expect it to vary. And when it says to vary, that means how it could be different. Explain why. Exercise 1 shows you an example. So the topic they gave was for each student in your school. So your job would be to come up with what's some numerical data that could be collected for each student in your school. You could find the length of time it takes each student to travel to school in the morning. And the next question is, would you expect this data to all be the same, or would you expect it to vary? Well, we would expect it to vary because students live different distances from the school. Not everyone's amount of time it takes to get to school would be the same, so it would vary. All right, so number 2, for each student in your class, what is something that we could ask about numerical data? Maybe we could say the number of siblings each student has. So that's some numerical data we could collect. And the next question is, would we expect that information to be the same for all the students in our class, or would we expect it to vary? And we would expect it to vary. Why? Because not everyone has the same number of siblings. Okay, the next question says, for each sixth grade student in your state, so in the whole state of Washington, what is some data that we could collect? That would be, the answer would be in numbers, that's numerical data. Well, we could ask maybe the age of each student. Okay, now do you guys think that if we ask the age of each student, that information for sixth graders would be the same, or it would vary? I would say it would still vary. I think it would vary probably between the ages of mostly 11 and 12. Most kids are 11 in sixth grade, and sometime that year they turn 12. But some students enter sixth grade when they're 12 and they turn 13. So it's a little different for everyone. The age of each student, and then we would expect that to vary. So not everyone is the same age. So if we collected that data, it would be similar data, but it would not be the same for everybody. Number 4, for each teacher in your school, what could we ask about all of them where the answer would be in numbers? Maybe we could ask the number of years they've taught. Okay, would we expect that number to be the same for everyone or to vary? Well, I think that's pretty obvious. We would expect it to vary because not everyone started teaching at the same time. right? Some people became teachers a long time ago. Some people started just this year. It would be different for every teacher. Okay, so write your own example. All right, so first we would need to come up with who are we going to ask. What if we asked we could ask the kids at McGee, so all the students in the school, how many hours they spend on homework daily. Now, would we expect that data to come back the same for everyone or to vary for everyone? Well, again, the information would vary because not everyone takes the same amount of time to do their work. There's a lot of other reasons why it would be different as well. Some teachers do not give homework. Some students choose not to do their homework. There's so many different variables here. So basically on all of these, we would expect all the data to vary. Now, occasionally you'll get numerical data that does not vary, but the point is that most data that you collect will vary. It will be different. So now we're going to compare some numerical data. So this example says fitness testing sometimes involves the number of crunches that can be completed in a given length of time. Crunches are sometimes called sit-ups. The data below show how many crunches a group of 6th grade students from 2 classes were able to complete in 1 minute. So in Miss Jackson's class, here's how many crunches each kid could do in a minute. And in Mr. Ryan's class, here's how many crunches each student could do in 1 minute. So we're going to use the data from these tables to answer the following questions. Consider the question, which class did better in crunches? And why is this a difficult question to answer? Well, who did better in crunches? So it's already telling us it's going to be difficult. Why is that? Let's see, 36, 32, 44, 36, 37, 41, 39, 32, 44, 36, 44, 31. Well, first of all, I think a lot of their data is similar, so it's difficult to tell just by looking at it who did a better job. If we look at maybe the lowest, we have 32 is the lowest. What's the lowest in the other class? 31, but they also have another 32. So let's see, the highest this group did, somebody did 44. In this group, the highest was 44. Yeah, so I would say a lot of their data is similar, and also the best and also the worst is very similar in each class. So it's really hard to tell which class did better. This is not an easy way to decide who did better by looking at these two tables. So the next question says, well, what are different ways you could display the two sets of data so the sets would be easier to compare? So they have this in a chart, and it's just by student's name, and all the numbers are mixed up. So I think one way is you could organize the data so it would be least to greatest. It would be easier. I think another way is maybe if we graphed it, it would be easier to see. So graph with each class next to each other. And I'm kind of envisioning here like a bar graph maybe. Maybe that would be the best way, because you could compare how many students had a low number, how many students had a high number, and you can kind of compare their graphs. So number 8 says, choose one of the ways you named in exercise 7, why would that way make the data easier to compare? Okay, so I said you could organize this data, like make it all least to greatest, or you could graph. Why would that be easier? Well, I'm going to go with graphing. So I'm going to say graphing could easily show who had higher numbers by looking at the bars. So when you look at a bar graph, it's easier to tell because you have that kind of picture to help you figure it out instead of just looking at the numbers and having your brain figure it out. The picture makes it easier to tell. All right, so in our next page, it says, look again at the crunch data. The data is numerical, so this is the same data, Miss Jackson's class and Mr. Ryan's class. It's the exact same data as over here. But this time they organized it in something called a dot plot. And a dot plot displays the frequency of numerical data. It uses dots to show how often numbers occur. So basically what they did is they said we have a 36, a 32, and a 44. So they put a dot on 36, 32, and 44. Then they put a dot on 36. Ooh, another one on 36, 37, and 41. So 37, 41, and another one, or the first one on 39. Then they did the same thing in this table. So all of these dots here came from this information. So the data tables show how many crunches various students completed. Is the number of students shown in the tables the same as the number of dots in the plot? That's a pretty simple answer. Yes. The number of students in the tables is the same as the number of dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these represent the 12 kids. 1, 2, 3, 4, 5, 6, 7, and 8, 9, 10, 11, 12. So 12 kids in the table and 12 dots here on the graph. Yes, they are the same. How does the dot plot represent the data in the tables? Okay, well basically each dot represents one student and the number of crunches that student completed. Okay, so each of these dots here represents a student and how many crunches they did. So for example, on 44, there's 2 students here that did 44 crunches. Just like in the table, Tyler had 44 crunches and so did Omar. So we can see that 2 kids had 44 crunches. Number 11, in the dot plot, there are 3 dots above 36. Which 3 students did the dots represent? And explain how you know. Okay, so the 3 dots above 36 are right here. Which 3 kids did that? Well, I can see who has 36 next to their name. And let's see who that is. So 36 would be Lucas, Alexis, and Leah. Okay, so on our next page, we have a little bit more information working with dot plots. It says use the dot plot below for exercises 12 through 15. The dot plot shows how many letters are in the last names of a group of students. Okay, so here's the number of letters in students' last names. So how many students does the dot plot represent? Explain how you know. Okay, so if I want to know how many kids are represented here, I can count all the dots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I can count all the dots, and there are 17 students because there are 17 dots. Okay, and how many letters do most students have in their last name? Okay, well, it seems like most students would be like more than half of the 17. So I'm thinking like more than 8 students probably have this many. So most students have maybe like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Kind of like right here maybe. Just by looking at the graph, I would say most kids have 4 to 7. Okay, so most kids have 4 to 7 letters in their last name. And there wasn't like a rule that I used to do this. I just kind of looked at it and I thought, well, where are most of the kids in this graph? I would say most of the kids are right here. I could have made that box bigger, but I just kind of thought most would be like more than half of the kids, and more than half of the kids are represented in this little section, which would be 4 to 7. So 4 to 7 kids have most, or not 4 to 7 kids, 4 to 7 letters in their last name is kind of the most popular of what the kids have. Do more students have short last names or long last names? And explain your reasoning. Well, I'm going to use kind of a similar strategy to what I did before. I'm just going to kind of look at the graph here. I'm going to go, well, I'm going to say that a short last name is going to be, let's see, the biggest one is 11 and the smallest one is 2. So halfway between 11 and 2 would be right here. Okay, and so I would say a short last name would be, this is just my interpretation, short last name would be 0 to 6 letters. Oh, I guess just to change that to a 1. Like, why would you have 0 letters in your last name? And then a long last name would be 7 to, here, this looked kind of messed up. Should say 1 to 6 letters. 1, 2, 6. There we go. And this one can say 7 to 11 letters, just based on the information in the graph. So do most students have short or do most students have long? Well, let's see. How many are short? So 1 to 6 would be 1, 2, 3, 4, 5, 6, 7, 8, 9 kids. How many kids have long? 1, 2, 3, 4, 5, 6, 7, 8. So I would say, to me, depends on how you define short and how you define long. Like, is it a short last name or a long last name? But based on mine, they're pretty equal. I'm going to say almost equal, but more kids, just one more kid, have short last names, based on the way that I cut up the data. Okay, write your own question about the dot plot. Exchange papers with a classmate and answer each other's questions. Well, obviously we can't quite do that last one because we can't exchange papers with anybody on a video. We're not in class together, but we could come up with our own question. I'm going to say, where would your own dot go? So for me, I have McPeak. So I have 1, 2, 3, 4, 5, 6 letters. So I would put mine on the plot right here for 6. I would be adding a circle or a dot above the 6 because for my last name, I have 6 letters. All right, guys. Well, that wraps up lesson 1 for Unit 8. Kind of short. If you have any questions, let me know.